Okay, so we developed this expression for electric field from a disk. So if we considered what would happen if we made the disk infinitely big, so radius is infinity, we find this expression goes to 0, and so we get this as an expression for infinite plane of charge. The electric field produced that infinite plane of charge produces. So it does not matter how far you are away from the plane of charge, the electric field is going to be constant. When do we actually see this? Well, if you consider the electron a sheet that's like 1 inch by 1 inch, that's infinite from the electron's point of view. So think, pause the video. Correct answer is C. Both have the same acceleration because the electric field is constant regardless of how far you are away from it. And so if we have two parallel plates now charged oppositely, as we have in a capacitor, this plane of charge is positive, creates an outward directed field going this way and this way. This guy has a negative plane of charge, creates an electric field going inward on both sides. So it creates this one and this one. Where you see them overlap here, you have two of them in the middle combining together. Does not matter how far away you are, right? Because it's an infinite plane of charge. And so in the gap, we get this expression. And this is the equation that you had for electric field in a capacitor. And this is why that I had you write K as 1 over 4 pi epsilon naught. All right with that? Right. And then outside, this one's being created, this field's created by the positive. This one is being created by the negative, and they cancel each other out. Because the amount, like how far you are away, doesn't matter. Here, same thing. This electric field is being created by this guy. This one's being created by this guy, and they cancel out. So the only field you have is in the middle, which is doubling that. Good. So here we had this. This is the slide that you saw last year, maybe. I showed you this slide at the beginning in the review. And then you also have this. The electric field is constant. It's electric potential difference. So electric field times the distance finds the electric potential difference. Good? Okay, so this is ideal capacitor. In reality, they're not infinite. Okay, but in the middle here, it's pretty doggone good. Okay, towards the edges, you get these fringe fields, and on the outside, they're technically some electric field because it's not an infinite plane of charge. Distance does matter at some point. Good? All right. So factoid. Charge on a conductor will always, and static electricity reside on the outer surfaces of the conductor. Okay? So if we have a charged metallic conductive sphere, special case scenario, but that special case scenario is very popular in this class. What we have is we have a certain amount of charge over the area of a sphere, 4 pi r squared. Good with that? Everybody tracking so far? Okay, so surface charge density. It's charge, the entire charge. So capital Q is the charge of all of this combined amount over the radius. Sorry, over the surface area. Okay. So if we are outside of the radius of that sphere, this acts like a point charge. Remember how we could approximate a planet with uniform density to have the center of mass at the center, and then the gravity behaves as if all the mass is concentrated at the center of mass. We went from the center to the center. We have the exact same idea here. Or kind of like the hollow planet thing. And on the inside, the electric field is equal to 0. That is the hollow planet straight away. Good with that? And that's that junior high version of saying why it's cancels out. And I don't know what I'm doing here, what am I doing there, why do I even have this? I don't know what that's for.
Yeah, that looks like something about you taking a quality.
This thing, this stuff. Okay. Good with that? Just know that like it's 0 in the middle and you're good. All right. That's it. So hopefully there's no other mention about flux on the rest of the 3 responses.
There it is. That's alright.
Is there?
Yeah. Just skip it.
Yeah, skip that portion. Hopefully it doesn't feed into
Yeah.
a lot of other things.
I don't realize that.